Last time we talked about the operational amplifier, okay, op amp, or we can call this device as op amp. Okay, I will remind you again what we talked last week, and then I will finish this slide. I think maybe within 1 hour, right? And we continue the next slide. Hopefully, let's see when we can finish this slide or not. Okay, to remind you again for the operational amplifier or op amp. So there is two parameter we call gain and frequency. That's the response, and mainly we will focus on the gain. The gain is to amplify the signal. Okay, we have some signal, we amplify this signal with some gain. So with the op amp, when we calculate or we analyze the circuit with op amp, so the main parameter is the gain of our circuit. So what is the gain? For example, if I denote the gain by A, and we have one circuit with input and output. V out, the relation between V out and V in we call gain. Right? Okay, so we can increase our signal with this circuit. Usually we use op amp in this type of circuit. Okay, so we have small signal and we can enlarge the signal, right? Like this. So there is many application and many type of circuit we use in the application of op amp. Okay. For example, the speaker, right, in the audio system, this the microphone also, right? We can speak not loud, but we can get the louder sound, right? Okay. And also in the industrial system, we will have the small signal from our sensor because we need the accuracy, right? This type of signal is very small. So if we change temperature to voltage, for example, the relation between temperature and volt, right? This voltage is very small, but when we get into the control circuit or to drive some device, so we can enlarge this type of signal, right, by amplifying. Okay. This is the ideal of the amplifier characteristic, right? We have VL or V out, like I said, it's V out, and we have Vs as our source, right? V in or V in, V source, right? And for the ideal op amp, so we will have internal resistor here, and we have the voltage control source here, right? This volt will depending on the voltage here. Okay, and usually R in is very large. R in is very large, and I in is going to 0, right? And when we send the signal, and the relation between VL and V in, V out and V in, right, is our gain, right? And this VL is depending on Vs here. VL is related to Vs, right? If we get this relation, we can compute the op amp. So we will focus on many circuits that use op amp. Okay. Okay. Whatever Vs just enlarges, right? And in this case, V in is equal to R in here. First, we see this on the left hand side of the circuit. The relation between V in and Vs, we can use voltage divider, right? The voltage divider will say that V in is R in divided by Rs plus R in into Vs, right? Here. This is the left hand side, right? And then we have AV in here in the right hand side of the circuit, right? VL would be RL divided by R out and RL, right? Here, RL. What mean by R out? This is the property of the circuit. So usually when we have the device usually have resistance, out resistance, right? If we have the capacitor like this, the actual device of the capacitor is you have small r, that is the internal resistance. Okay. Okay, so this is the right hand side of the circuit. Then we substitute V in here. We substitute V in. Then we get this relation, right? R in divided by Rs. And R in divided by Rs plus R in. And RL divided by R out plus RL, right? Into A and into Vs. Okay, you can follow? Okay, yeah. So this is the relation between VL and Vs for this circuit. Okay, and it's depending on the gain of this device, this A. Okay. Yeah. So this is the relation of this simple voltage amplifier. We call voltage amplifier to increase Vs. The Vs may be small signal and we get VL, the larger signal, right? This is if this term is more than 1, VL will enlarge Vs, right? If this term is less than 1, it's decreased, right? The magnitude of the signal. Okay. Yeah. So in this case, if we consider Rn is very large, and then I in is going to 0, yeah, then Vs and Vin are approximately equal, right? If Rn is very large, it's almost open circuit and no current flow here, so the voltage here is equal to Vs. Okay, is equal to Vs. Yeah, like this. And then if we take the limit here, Rin is very large and Rin is very large, so this term is going to 1. Yeah. This term go to 1. Right? This is a very large value and this is a very large value here. Okay. And then VL here, sorry. VL would be AV in. VL is AV in here. Because this is V in, right? This is V in here. So this is become AV in. So VL is AV in, right? And V in and Vs are approximately same. So we get VL is AVs. VL is AVs. Okay, it's the gain of the circuit, right? So we just don't need to concern about R in and R out in our circuit, like this. this is the ideal op amp. Okay. For example, if V in is 10, we have the circuit with the gain of 5, for example, gain of 5, and V in is 10. V out would be 50. Okay, okay. And this is the practical op amp. Okay. So usually we use the IC number 741 as the op amp here. Okay, this we have input and output here. The output in here, the input in here. So with this two input, if we connect these two input with some source signal, we can get the output signal maybe larger like this. Okay, but in practice, this type of device will need the power supply, right? We need supply here, positive supply and negative supply. Okay, so when we draw the op amp, we usually use the triangle symbol, right? We make negative. We have a negative pin and positive pin like this. This is V in, and this is V out. Okay, and we can control the gain by the circuit. We connect by the resistor. We connect to the op amp. Okay, and sometimes people also indicate that the op amp require the power source, right? This is power supply to supply this IC. Okay, the power supply for this IC. Okay, but usually it's not included in the calculation. Okay, it's not included in the calculation. So sometimes we don't indicate this. We don't need to draw this for power supply. Okay, I think you get it. Okay, this is a pin of. Okay, and then we can draw the op amp just like this. This is a positive power supply, negative power supply, and sometimes we don't indicate this. Okay, but it's there. Okay, it's there. And this is an inverting input and non-inverting input. Like this, inverting input is negative, and non-inverting input is positive. And this is output. Okay, this is V out. This is V inverting is V negative. Non-inverting is V positive. Like this. Okay. Comparing to this. This is inverting, is negative, this is positive. This is in flip position, right? This is which is inverting. This is non-inverting. Okay? And this we have the gain of the op amp. So this type of device will have the open loop gain, we call A. The open loop gain is very large value. For example, 10 power 5, 10 power 7. So this is very large value. For example, 10 million times. Right? If we input if we input 1 volt here, we will get 10 million volt on another side. This is ideal, right? In fact, it's not possible to do this, right? This is 10 million volt. This is we call open loop gain. So usually we will connect the op amp by have the resistance to feedback the value like this to control the gain. To control the gain. Okay. So many types of resistance circuit to connect to the op amp. Okay. we will learn how to calculate, how to control the gain of our amplifier circuit. Okay, first of all, the circuit we call inverting amplifier. Inverting amplifier means we connect the negative feedback, we call RF, the feedback resistance. This is feedback, right? Resistance back here to the negative pin, right? The inverting input, yeah, the inverting input, and this is non-inverting input. Okay. So if we connect the op amp like this, we can analyze as if we take KCL here. KCL here, that is IS plus IF equal to IN, right? IS plus IF, IS and IF equal to IN, right? Okay, and IN is approximately 0 because inside the op amp the internal resistance is very large, right? It's very large here. So IN is approximately 0. So IS equal to minus IF, okay, in this case. So there is no current flow here. Okay. And IS, what is IS? IS will be VS minus V negative, right? Divided by RS. This is IS, right? This is V negative. This is VS here. VS minus V negative divided by RS here. And what is IF? IF would be V out minus V negative divided by RF, right? And these are equal but in negative term, right? So IS equal minus IF. It means that VS minus V negative divided by RS equal to minus V out, right? Minus V negative divided by RF, like this. And V out, and if we consider V out, V out is the voltage across input into open loop gain, right? Here is the property of op amp. Whatever V in, V out will equal to open loop gain into V in. Okay, so in this case V in is V positive minus V negative here, right? And now V positive, we make its difference 0, right? So V out would be minus open loop gain into V negative. Yeah. And so V negative would be V out divided by the open loop gain. So note that this is a very large value. Okay. Okay, here VIS is negative IF, then VS divided by RS here. VS by RS minus V negative by RS equal to minus V out by RF plus, right, V negative by RF. Then we substitute V negative by this value, by this value. Okay, and then we get this equation. Okay, V negative is V out by R. This is V negative, right? With the negative value, right? Okay, like this. Then we rearrange by move this term to the right hand side. We get Vs by Rs equal to V out by Rf minus V out by open loop gain Rf minus V out by open loop gain Rs, like this. And then V out, Vs would be, we put Rs here, right? So it will be Vs equal to Rs into this term, right? Minus Rs V out by Rf minus V out by A open loop gain Rf minus, oh no, plus now, plus because we put negative here, and V out by A V open loop Rs here, right? So to multiply with Rs is equal to V divided Rs to multiply, this means V out is divided by 1 by Rs, right, into this. So we if Rs, we can represent Rs here, or we can represent Rs here, right? Divided by Rs divided by Rs, like this, and then this cancel to 1, right? So we get this term. So if we consider the open loop gain is very large, yeah, it's very large, this is very large, so this term is going to 0, this term going to 0, so we get the relation of V out and Vs is V out is minus Rf by Rs Vs. Okay, right? Yes. So if I design the circuit, I put Rf 10 ohm and I put Rs 1 ohm, what happened? I will get the gain of minus 10, right? So the output will enlarge the Vs by 10 times, right? But in the opposite direction. Okay, so if Vs is 2, so for example, if Vs, if I put this value, I put this value, and we send the signal 2 volt, what happened to V out? V out would be minus 10 by 1 into 2, then we get minus 20 volt, right? So from 2 volt, after pass this circuit, we will get minus 20 volts, so the signal is enlarged, but in opposite direction. Okay, in the opposite direction, right? Yeah. So we call this type of circuit as inverting, right? We invert the signal and we amplify it, so we can control our signal, we can enlarge the signal, but know that it will invert, right? The signal will be invert here. Okay. So by proper design of RF and RS, we can get amplifier signal. Okay, amplifier circuit. Okay. Right. So this is the relation of V out and Vs in the inverting amplifier closed loop gain like this. Okay, so usually we use the amplifier with closed loop circuit, right? Closed loop gain. So V out is, in this case, if you find this type of circuit, V out will be minus F by S into Vs, right? So this is the ideal op amp with the gain, open loop gain very large, right? But in fact, this would be maybe 10 power 7 like this. Okay, 10 milliamp like this. Okay. Maybe A of the op amp usually is have the range from 10 power 5 to 10 power 7. Okay. Yeah. Here is the AVO approach to infinity. In this case, if we open loop gain go to infinity, V negative also 0 like this. So V positive and V negative is usually equal in the op amp with negative feedback. Okay. Or we can consider that the internal resistance is very large. Rin is go to infinity and In is go to 0. So then usually V positive and V negative can consider equal. Okay, approximately equal. Okay. Virtually 0, right? If we put V positive to 0 volt, V negative is virtually 0 also. Okay, in the inverting amplifier, and I in is virtually 0. This is the property of op amp circuit. Okay. Yeah. Yes. For ideal analysis, we can just use this simple formula. If we know RF and we know RS, we just directly use this shortcut equation, right? Shortcut formula to compute the gain. Okay. And when we analyze the op amp, so the key rule is In is virtually 0, right? And V negative and V positive are virtually equal to each other. Okay? This is a property of op amp. Okay, now let's see. If we consider the value of A, here, this is an example. If we not neglect this term, usually we neglect this term to 0, right? So if we not neglect it, we does not neglect this term, these two terms, right? So if A is 10 power 7, this is 10 power 7, and if RF and RS is 1000, for example, this is 1000 ohm, and this is 1 ohm, like this. This is 1000 ohm, this is 1 ohm. We substitute RF by RS, RF by RS, like this. And we will get the relation between V out and Vs. If A is 10 power 7, we get 999.1. Right? But ideally it is 1000, right? So there is some error there, right? Some approximation is there. But if A is not large, right? If A is 10 power 4, we get approximately just 900, right? We get a larger error, right? The larger error here is not 1000, right? So in case if A is 10 power 6, 10 power 6, we will get the error of 0.1. Okay? Here. If you substitute 10 power 6 into the closed loop gain, right? The error is just 0.1%, so it's acceptable to use this. It's acceptable to use this formula, right? Okay, in the computation, right? To get the signal, to enlarge the signal. Okay, any question? Okay, this example just to analyze the error of the resistance when we when we connect the resistance RF and RS, and if the resistance have some tolerance, you know the tolerance of resistance is the error, right? If we say it's 10 k ohm, it is have error plus minus 5%, what happened? If the error is plus minus 10%, what happened, right? What happened to our circuit? What is the error? It affect error to our circuit, right? Okay. So this example just compute with 5% error and 10% error, right? And you see the range, we get the range of the output. Okay. I think I will leave this example for you, right? Just to show that if our resistance is not 1 k ohm, it's 1 k ohm plus 5% minus 5%, just like that. Okay, and I think you can make your understanding by yourself here. Okay, and this circuit will enlarge the signal, right? This is Vs, this the dark line, and the dark line is Vout. You can see that if Vs is in the sinusoid function, right? It's sinusoid function here. We have cosine function in the dark line here, the bold line, and the dot line would be Vout is inverse, right? Increase the magnitude, but in inverse position, right? It's not invert in the same position, right? So we call inverting amplifier, right? Okay. Oh. we cannot go to digital circuit today, right? Okay, but okay. Now come to the next type of op-amp circuit. We call summing amplifier. So the first circuit we call inverting amplifier. So just to show you first that there is maybe many type of op-amp that we talk today. Summing amplifier, non-invert. We have inverting amp. How to make non-inverting amp? How to make the op-amp circuit without inverting the signal, right? It's another type of signal. The voltage follow the differential amplifier. This is example. Okay. So now we come to the summing amplifier or op-amp summer, right here. So if we connect the circuit like this is VS1, VS2, and VSN. So many. Yes. And this is RS1, 2, like this. And this is RF. Again, this is a negative feedback here to the negative input, and this is Vout. This is V reference, the positive pin here. We call summer op-amp summer, right? So in this case, if we take KCL here, I1, I2 until IN is equal to minus IF, right? Because I in here is virtually zero, right? Okay, this is virtually zero, right? This is the rule, right? Here. The current into the op amp is virtually zero, and the negative and positive pin are virtually same. Okay. So KCL here is I1 until IN is IF, and in this case I1, sorry, this is VS1, and this is V negative, this is V positive. So I in is approximately 0. V negative is approximately V positive because I in is 0, right? Yeah. So in this case, V positive, V connect is to ground, so it's equal to 0. Therefore, V negative is virtually 0, right? And here if we take KCL here, I1 plus I2 plus IT until IN is equal to minus IF, right? And what is I1? I1. What is I1? I1 would be VS1 minus V negative divided by RS1, right? And is would be if V negative is virtually 0 is VS1 divided by RS1, right? RS1. Similarly, I2 would be VS2 divided by RS2. I3 would be VS3 divided by RS3, and then for IN it will be VSN divided by RSN, right? For n equal to 1 to G until n. Okay. And what is IF? IF would be V out minus V negative, right? IF would be V out divided by minus V negative divided by F, and this is approximately 0. This will be V out divided by RF. Okay. And we substitute I and IF, right? We get this. So then VS1 divided by RS1 plus VS2 divided by RS2 plus until VSN divided by RSN will equal to minus V out by RF. Therefore, V out is equal to minus RF into the summation of VSN by RSN, n equal to 1 until capital N. Okay. So we call this type of circuit as summing amplifier. So it's something. It makes a summation of the source, right? Yeah. So many types of source. We increase the signal, but we sum the signal. We sum the signal into each other, right? For example, if I make this circuit, source. Now, if this is maybe 100 ohm, okay, and I put here 1 ohm, 1 ohm, 1 ohm, this is V out, this is V1, V2, V3. So what is our gain? Can we write down V out? V out would be minus RF, right? 100. And then V1 divided by 1 plus V2 divided by 1 plus V3 divided by 1 is become minus 100 with V1 plus V2 plus V3, right? This is V out. So in this circuit, V out will equal to the summation of 1, 2, and 3, right? V1 and also increases 100 times, right? With the negative sign, okay, with the negative sign. Okay, this is op amp summary, okay, op amp summary. Okay. Okay, next come to non-inverting amplifier. Non-inverting. Okay. Non-inverting amplifier, again we put the negative feedback. Okay, the negative feedback. And we input the our signal to the non-inverting pin here. Right? So if we take KCL here again, at the inverting input or negative input here, we get IF. IF is I in plus IS, right? Yeah, IS. Yeah. And IN is approximately 0 again, right? Yeah. With the very large value here. Very large, yeah, very large resistance. So IF and IS are same. Yeah. Right? And what is IF? You see here. IF would be V out minus V negative, right? V out minus V negative divided by RF, right? Yeah, IF. V out divided by V negative by RF. Okay. And what is IS? IS would be V negative minus 0, right? Divided by RS. Okay? Okay? Here. Okay. And in case the current flow is virtually 0, V positive will equal to Vs, right? Because no current. So V positive equal to Vs, and V positive and V negative are approximately equal, right? Here. This is the rule, right? This is the rule here. So we get V negative and V positive are same, and it's equal to Vs. And IF and IS also same. We can substitute Vs here and Vs here, and these two terms are equal, right? So we can get V out minus Vs divided by RF is equal to Vs divided by S, right? We rearrange this term. So Vs then to rearrange this V out by F minus Vs by equal to Vs by S, like this. What V out equal to F into these two terms, right? Vs by Rs plus Vs by F, like this. So we can move Vs from the bracket and then it become F Vs 1 by Rs plus 1 by Rf, right? And if we put Rf into the bracket, we will get Vs Rf by Rs, and then it's become 1, right? So we get this relation, right? And this is the gain of non-inverting amp. If we select F and Rs properly, we can increase Vs by this relation. This is V out. So for example, if I put F at 100 and Rs is maybe 2, what is our gain? V out would be Vs and what? 1 plus 100 divided by 2, then we get the gain of 51, right? Vs into 51, right? Okay, so whatever the input signal, the output will increase by 51 times, right? Without inverting the signal. Now, with this type of circuit, we call non-inverting amplifier. Okay. Now, we have been talk about inverting amp. This is a formula. Summer amp is a formula, right? Sum together. Non-inverting amp. Yeah. Okay. This is non-inverting amp. Okay. The next circuit is just the voltage follower, just the same as input. Whatever the input, the output are the same. If we connect the op amp like this, we will get the output. Just follow the input. We call voltage follower. Okay. If you follow exactly what the input is, if we connect like this with negative feedback. Okay. So note that usually we connect the op amp with negative feedback like this. And the next circuit is a differential amplifier. Is will get the difference between two sources, V1 and V2. We get how different of V1 and V2. Okay. So in this type of circuit, we connect R2 here and R2 here at the same value, and R1 here and R1 here. Okay. Then V positive here. V positive is, if we consider is closed loop, and we use voltage divider. What is the voltage across R2? We can use voltage divider, right? The voltage across R2 would be V2 into R2 divided by 1 R1 plus R2 here. This is V positive, right? By voltage divider. Okay. And I1. So this is V positive. And V, note that I in, right? I in is virtually zero, and V negative and V positive are almost the same. So this is V negative. So V negative and V positive are almost the same. So I1 would be V1 minus V negative, right? I1 will be V1 minus V negative divided by R1, and V negative and V positive are same, right? Right, with negative feedback here. And I2 here, I2 is V out minus V negative, right? And V negative and V positive are same, divided by R2. And this I1 and I2 are equal, right, with opposite direction. Then we can get V1 minus V positive divided by R1 here equal to minus this term V out minus V positive divided by R2 here. Okay. And then substitute V positive by this term. It's become a complex formulation, right? And finally, we can rearrange into this. Okay, if we substitute V positive here, our equation will remain only V out and V1 and V2, right? V out and V1 and V2. Then we rearrange into this formulation. So if we sum these two terms together, it means that we just multiply R1 and R1 here, right? If I multiply R1 by R1, okay, to this term, we can sum these two terms together, right? And this becomes R1 plus R2. R1 plus R2 will cancel each other. We remain V2 by R1, right? You get this term is become V2 by R1. And then V out will be V2 R2 minus V1 by R1 plus V2 by R1. Okay, and we can get this final formula. So this type of circuit will subtract the input, right? V2 minus V1, and this is the gain, right? Again, we call differential amplifier. How different of our signal? Okay, we get the output of how different of our two input signal. Okay, so you can see that many applications with this IC. Okay, it's 8-pin IC. Okay, with our when we connect the resistance to this type of IC. Okay. You already touched this, I see, right? In the lab. Not yet? No? No op amp lab? No?
No.
Today? No? Maybe.
Tomorrow.
Tomorrow. Right? This one? You know the pen. Did Jim give you the laboratory pen, right? No? You don't know what to do tomorrow, you don't know, right? You have no document?
Not yet.
Not yet, right? He will give you tomorrow, right? This evening, or usually this evening. We don't know yet, right? But you didn't do this yet, right? Okay, it's good that you study theory first, right? Okay. So far, any question? Is it differential? Okay, differential and oh, okay. The time is about right. For example, if I put R2 for maybe 10 ohm, 10 ohm, this is 1 ohm, this is 1 ohm, and V2, V2 20 volt, and V1 15 volt. What is the output? V out would be 10 divided by 1, right? And the difference between two input is 20 minus 15, right? So we get 10 and 5 volt, right? 15 volt, like this here. That's different with some gain, right? With some gain. And if we put the gain of 1, if we put 1 ohm, 1, 1, 1, 1, the output is just right V2 minus V1, right? Okay, if we put R2 and R1 the same value, if R2 and R1 the same value, we will get output just the difference between our two sources, right? How much the difference of our source. Okay, this is the some example. What is this circuit? Inverting amplifier, right? Inverting amplifier. Inverting amplifier, the formula is just like this. Okay. If R2 is 5K, R1 is 10K, V in is 1 volt, so what is V out? Negative 5, right? 1 volt, we get negative 5. Okay. So if you found the circuit with the standard circuit, you learn is you can use this formula directly. If the circuit is not in standard form, you need to analyze like this. Okay, it's a bit complex. You need to analyze in this with this method. Okay. And what is this circuit? Again, this is the inverting amp. Okay. Because in this case, R1 is potentially 0. Right? This is inverting amp. So I in is approximately 0 and V1 is 0. When V1 is 0, V negative is also 0, right? It's 0 here. So it's a basic inverting configuration, just some different here. If we put the resistance here, or we don't put it, it's the same, right? It's just 0, right? It's 0. Yeah. So it's the inverting amp. If R, this is 10 and this is 2, right? The gain would be 5, right? Negative 5 is our gain. Yeah. Okay. the voltage across R1 is 0 because the current is potentially 0, right? Here, I is 0, so it's 0. Oh, we can analyze, this is 0 volt, this is also 0 volt, right? And this is the current, and this is the current here, right? And it's become, it's just similar here, right? It is 0, right? This is the resistance here. We don't need to consider this. Right? This is a inverting amp. Inverting amp. This is also inverting amp. Okay. You can take photo, or you can wait for the video capture. Okay? But don't rely on my record. Right? And what is this? This is not standard, right? We have VA and we have VB, right? VB is 2 volt and VA is 5 volt, right? Here. Just like we have VB of, for example, is similar to we have VB of 5 volt. And we have VA of 2 volt, right? Okay, like this. And R1 is 14 ohm. R2 is 11 ohm. So we can take KCL at this node. Here, V negative node. Okay. And this is V positive node. Okay. And this is VB, right? V positive equal to VB. And then V negative also VB. Because we force this pin at 5 volt, this also 5 volt. Right? And the current is 0, right? Current here is 0, like this, right? Get this, because this is 5 volt, this is 5 volt, and that's 5 volt also. Right? The rule is V positive and negative, almost same. And the current flow inside the op amp is almost 0. Okay? Then if I say this current IR2 and this is IR1, it means that IR1 equal to minus IR2 or IR1 plus IR2 is 0. Average IR1 is VA minus VD, right? VA minus VD. This is become VB now. VA minus VB by R1. IR2 is V out minus VB by R2 here. This is our formulation, and we can substitute VA and VB, right? VA and VB together. We get V out, right? Okay. This is in fact differential amplifier. Differential amplifier. Okay. How about this? Similar to this, right? Just similar. Okay? So you can analyze this. If you take KCL at B negative, this is become 4 already. This is 4 volt and this has become 4 volt, right? Then we take KCL here without the current flow here. Okay, this is the rule of analysis, right? So 5 minus 4 divided by R1 equal to V out minus 4, right? But in this case, we use this direction. This is I2 and this is I1. So I1, I2 are equal, right? 4 minus V out, 4 minus V out by 4. Right? Or if we analyze as before, this is IR1, this is IR2 here. So 5 minus, this is V negative, right? Or is equal to 4 now. 5 minus 4 divided by R1 equal to minus V out, right? V out minus 4 divided by 4 ohm, right? Here, right? This is same. Okay. Then we substitute R1 by 1 ohm and R2 by 4 ohm, right? Oh, sorry, this R2. We get like this. In this case, we left R1, R2 in our analysis until we get V out is 4 minus R1. 4. R1 by R2 and 1. Okay. And then 4 minus R1 by R2, 4 becomes 0. It's a differential amp, but the gain is 0. We got the gain of 0. Okay, how about this? This is non-inverting amp. Okay, this is non-inverting amp. But the question is not to compute the gain, but to compute R1 to get the gain of 10. Okay, a bit complex, right? So they don't ask what is the gain, but they ask how to get R1 that make the gain at 10. Okay, 10 now. So this is non-inverting amp. At the non-inverting amp, you have the gain here. This is the gain. The RF, RS, right? This non-inverting amp is here. RF and RS is 1 plus feedback, negative feedback divided by R source, right? Here. Okay. So in this case, the gain is 1 plus R2 negative feedback is 18K divided by R1. Okay? And we would like this value to be 10, right? To be 10, right? So to get R1 that makes this value to be 10, then we can solve for R1. So R1 is 2K ohm, right? If you make this is 10. So R1 from here, R1 would be 1 by, oh no, it's, sorry, R1, 10 minus 1, 10, no, 18. Now let's do step by step. This will be 18, 10 power 3 by R1 equal to 10 minus 1, right? Right, 10 minus 1 equal to 9. So R1 is 18 divided by 9, right? It's become 2 into power 3. Okay, 2K ohm. Okay. Oh, one more. No, two more. Okay. Okay, how about this circuit? Determine V out. Okay, V is then R1 is 11 ohm, R2 is 18 ohm, and RF is 6 ohm. 6 ohm, right? Here, RF. And R1 is, this should be R1, right? 11 ohm. V1 is 4 volt. 6 volt. But RF 15, right? Sorry. RF 15. 15 volt. 15. Right? R1, R2, what is R3, right? R3, 6 ohm. This is 6 ohm. Maybe like this. Okay. How to get V out with this type of circuit? Yeah. We take KCL at the positive node. So this is virtually zero, right? This is also virtually zero, right? In this case, this is V2, and what is V of this node? Here we call Vx, right? Oh, V, in fact, it's V positive here. V positive, we can take voltage divider, right, of this circuit. What is the voltage here? We have this is 6 volt. V positive, in fact, is 6 volt into 6 divided by 18 plus 6, right? Yeah, just like this. R1, R2, Ri, this is Ri, I'm sorry, Ri, right here, Ri is this. And then, if we take KCL here, V2 minus V positive, V2 minus V positive divided by R2 equal to this current equal to this current is V divided by V positive divided by 6, right? Ri here. This Ri, sorry. Ri, like this. And we know that V is this. And also we take KCL here. The current flow here and the current flow here are equal with negative. Or we can get this current flow here and equal to the current flow in this direction also, right? So this is Vx, this is V negative, and they both are same, right? Vx, so we call this Vx here. This is V positive. V positive. So V1 minus V positive divided by R1 equal to V positive minus V out minus divided by Rf, like this, right? Here. And in this circuit, we can calculate V out here. By this equation, V out is Vx into 1 plus 1 by Rf minus the term of V1 minus Rf by R1 V1. Okay, this. From this, we rearrange to get V out, right? In the term of Vx and V1, Vx and V1, and Rf and R1. Okay? So I suggest you to check this. And then we subtract Vx here. Into this Vx value. Okay. Vx here. We will get this term. And finally, if we substitute V2 and R and V1, we get this value. On the other hand, if we compute the value of our parameter, right? This may be more simple, right? Like we can compute V positive here. We can get V positive. How much for V out? The V positive, how much? 6, right? 36. 1.5, right? We can get 1.5 volt here, right? This may be more simple to get 1.5 volt first, right? To compute V out, right? Then we get 1.5 volt here, we get compute V out here. 4 minus 1.5 divided by 11 is equal to 1.5 minus V out divided by 15, right? So check that how much we get for V out. Is the same or not? Okay, easier, right? Yeah. So in this case, they try to arrange the formulation without substitute the value, right? So it's depends on you can do by understanding, right? With the rule, the main rule is V positive and V negative equal, right? And I in is 0, so you can use your circuit analysis knowledge to solve with the rule of op-amp. Okay. I think this is the last, right? Okay. Okay, let's see this last example. This is a summing amp. Okay. We have V1, V2, V3 like this, and V1 is 1 volt. This is 7 volt. This is 4 volt. Right? R1 is 8 ohm. R2 is 18 ohm. R3 is 6 ohm. And RF, the negative feedback is 11. Right? This is in fact, we can use this formula, right? Is summing up. We can use the op-amp summer formula, or we can solve by KCL here, right? KCL here also. With KCL here, and this, what is the voltage here? What is the voltage here? This is 0, and this is then 0, right? 0 volt without current flow into here. So you can use KCL, right? 1 minus 0 divided by 8. 1 minus 0 divided by 8. Plus 7 minus 0 divided by 7 minus 0 divided by 18. Plus 4 minus 0 divided by 6, right? Equal to 0 minus V out, right? 0 minus V out divided by 11, right? So we can compute V out, right? This is the op-amp summer, but the op-amp summer with negative gain, right? It's become negative output, with negative gain. Not so difficult. Here. Op-amp summer. Summing amplifier. Where is summer? Summer, yeah. With negative gain, right? Yeah. Okay. So with this topic, you will have 3 problems for your homework with the answer is there. Okay. Try to do this until you get the same answer. Right? Try to substitute the value until you get the same answer, right? Okay. So what should be the due date of this homework? Next week? Next week is enough? Okay. Okay, next week for 3 question. Simple, right? Ah. So we have only less than 1 hour. Okay, you can take some break, right? You can, if you have question.